Have you ever wondered how your text message gets from you to your best friend? Or how the sun's energy reaches the earth and makes life possible? The answer is waves. In this chapter, we'll explore the physics of waves and learn how they transmit energy through space and time. To begin, we'll look at a simple device called a pendulum, which at first seemed to have very little to do with waves. A pendulum is a mass attached to a cable or a rod and can be as simple as a rock on a string. Pendulums swing back and forth regularly, so regularly they can be used as a clock or a musical metronome. The time it takes a pendulum to swing from one side to the other and back is called its period. Galileo discovered that the period of a pendulum only depends on its length. Mass has no effect. When two pendulums have different lengths, the longer one has a longer period. This explains why people with long legs have a slower stride than people with short legs. Pendulums have regular back and forth motion, something they have in common with all waves. So what causes waves? Waves are caused by vibration. When something moves back and forth, the motion is called vibration or oscillatory motion. The motion of a mass bouncing up and down on a spring is a form of oscillatory motion. The mass and spring system and a pendulum are both examples of what's known as simple harmonic motion. One thing that defines simple harmonic motion is that it can be represented by a sine wave, where the y-axis is position and the x-axis is time. If you attach a pen to a mass and spring and move the paper underneath the pen at a constant speed, it draws a perfect sine wave. Let's look at the parts of a wave. The high points on a wave are called crests. The low points are called troughs. The amplitude is a measure of the height of the wave from the midpoint to the crest or trough of a wave. The wavelength of a wave is the horizontal distance from one crest to the next. It can also be measured as the distance from any part of a wave to the next identical part of the wave down the line. Wavelengths can be almost any size. The waves on the beach are measured in meters, the ripples in a pond in centimeters, and the wavelengths of light in billionths of a meter. The number of vibrations a wave makes in a unit of time is called the wave's frequency. Units of frequency can be anything you count divided by a time. For example, cycles per second, revolutions per minute, vibrations per second, or waves per second. All these units mean the same thing: frequency. When the unit of time on the bottom is seconds, we use the abbreviation Hertz for the unit. Large frequencies often have metric prefixes like kilohertz, which is thousands of hertz, megahertz, which is millions of hertz, or gigahertz, which is billions of hertz. If you know the frequency of a wave, you can easily calculate the period of the wave and vice versa. They're reciprocals of each other. If a pendulum makes 2 vibrations in 1 second, its frequency is 2 hertz. That means the time it takes to make 1 vibration, its period, is half a second. Let's practice using this relationship. What's the period of a wave that has a frequency of 100 hertz? Okay, now period is equal to 1 over the frequency, right? They're reciprocals. So that means that we're going to take 1 over the frequency, which is 100 hertz, and let's put it in the calculator, and we come up with 0.01 seconds. There you go.